Practice exam 2, part 5. We are up to question 9, and we'll be doing proofs from here on out, more or less. So here's question 9. Once again, you will be presented with it, with your request to do proofs, or something like this. This is still in the definitions and questions sections, by the way, but you're asked to do proofs there as well. So you write your premises at the top, you justify them with the justification premise. You write your conclusion way down the bottom, right? Leave a whole bunch of space. Okay, and remember my advice for doing proofs in general, all right? Remain conclusion driven. That is your mantra, okay? Look at your conclusion. That's what you're asked to derive. You want to, I'm going to say, what is the structure of this conclusion, right? What is it? And what rule am I going to use to derive it? And you do get an answer here, right? If you are familiar, especially with the Unit 9 rules, okay? Because this is a case that you really are going to need them. What is the form of this thing? It is a negation, okay? Negations are legitimate conclusions of indirect proofs. And if you didn't use indirect proof here, this would be very complicated, right? If you were to work backwards, even, and you could use biconditional exchange, which should be clear is going to be needed somewhere here, from B and not C, getting the negation of B by conditional C. You could use biconditional exchange, right, and have negation brackets, and then the negation of the conjunction of B hook C and C hook B, right? But how ugly is that, right? And even trying to expand that to something else is going to be very, very hard. So much easier if you know how to correctly wield indirect proof, right? This is of the form of not P, so I'm going to assume P, right? Attempt to derive a contradiction and infer it that way, okay? So I am going to make the assumption of B biconditional C, right? So just look at the advantage that has already accrued to me, right? I've got as a formula now, this is justification by, assumption for IP, right? I've got as a formula now that I can play with and use and derive things from B biconditional C, right? I use biconditional exchange and I get a conjunction. From a conjunction, I can simplify, right? So much more easier than trying to deal with the biconditional exchange within a negation, with the whole thing negated. Right? So I believe there's also, right? This is going to be much, much simpler to work with. Okay. Now, let me reiterate the main point of the difference between conditional proof and indirect proof from Unit 9. Right? Remember, conditional proof, when you look at the conclusion, right? You put the premise here and the premise of the conditional you're deriving. Right? So if your conclusion is a conditional, it's antecedent hook, consequent, you put the antecedent at the top, and you put the consequent down the bottom when you're doing conditional proof. Consequent down the bottom, right, which gives you the specific particular formula that you're aiming at, right, and that is such that when you get to it, you've ended the subproof for conditional proof, right? So you've got a particular formula, right, whatever the consequent of the thing is. If it's, if your conditional is A hook, brackets, B and C, right? So the consequent is B and C. A is here, B and C is here, right? So you know, I'm aiming at the specific conjunction B and C, right? That's the big advantage for conditional proof. You know the particular formula that ends your subproof, such that when you get it, when you derive it, you discharge your assumption and you say, okay, now on this line, A hook brackets B and C, by conditional proof, steps, whatever this number is, 2 dash to whatever that number is, right? Indirect proof doesn't have that advantage, okay? Indirect proof, you assume the P for which you're deriving and not P, but you are not able to write down here the exact precise formula which marks the end of your subproof, right? If you do some practice with these Unit 9 rules, conditional proof, indirect proof, mastery of these rules comes with knowing when your subproof ends, right? The people who don't do very well with the use of these proofs are always flailing about within a subproof, not knowing when to get out of the subproof, right? Conditional proof, I told you how it went. Indirect proof, right? What's the form? We had it up before on the assume P, derive something of the form Q and not Q. That's the last line of the subproof, and then you discharge the assumption, move back to the main line to derive not P, right? So what I do is when I'm setting up for indirect proof, I put a little X here, right? Meaning I know that I have come to the end of my subproof for indirect proof when I have derived some contradiction. X marks contradiction, right? But here's in indirect proof, as opposed to conditional proof, in indirect proof you don't know exactly what the formula, what the contradiction will be. You know it's of the form Q and not Q, but you don't know, so you know you got to the end, you know you have come to the end of the subproof when you have some formula and its negation conjoined, Q and not Q, but, whoa, we're doing logic. Yeah, rub that out, please. It's incorrect derivation. But you don't know what the particular formula is, okay? So there's a little bit more vagueness going on for indirect proof. Okay, but we've got this. It should be, we just do some top-down reasoning and a contradiction should appear, right? So, of course, I've got 3, right, 4. I'm going to do the biconditional exchange. Biconditionals, you pretty much always use biconditional exchange. So this is equivalent to B hook C and C hook B by B E3. Okay, 5 and 6 are going to be simplifications. B hook C, C hook B, simp of 4, simp 4, simp 4. Oh, wait, we're doing a proof. B hook C and C hook B. Okay, you see that? Biconditional exchange, that's the conjunction. I simplified to get the 2 conditionals that are the conjuncts of this. All right, and now there's 2 moves you can make to get your contradiction. Don't forget the premises. These are formulas you're entitled to use in making derivation. So I've got B, I've got not C. I'll tell you the 2 different ways. So one way, C, I've got C. Notice that I've got B and B hook C, so I could modus ponens to C, right? So C, modus ponens, 1 and 5, right? Now I've got C and I've also got not C. Am I allowed to bring this in? Of course you are, yes. You can use the premises. Talked a lot about that in Unit 9, in the lectures, and the book does as well, right? Within a formula you can appeal to and use all the formulas to the left, right, on the main line above, but when you're outside the subformula, you are not allowed to appeal to formulas within the subformula after you've discharged the assumption, right? Because these things are only true under the assumption made, whereas these things are supposed to be absolutely true, or true only assuming that the premises are true. So true in the context of the proof. All right, so that was one way. So you derive C. Please be aware the last line of an indirect proof has to be of the form Q and not Q, so you do have to make the conjunction. You can't just write C, oh look, I've got C and not C, I've got a contradiction, so I'm done. No, you've got to write C, modus ponens, 1 and 5, and then next line, C and not C. Conjunction 2, 7. Conj 2, 7. That would be the last line, and then this would be indirect proof. It's proven. That's one way to do it. Notice there's another contradiction I can get. B and not C. I could use the not C and do modus tollens on 2 and 6. Sorry, 2 and 5. Modus tollens 2 and 5, and I get not B. So the other way, right?
I think you didn't say nothing that clear.
You don't think I'm saying clearly enough?
Yeah.
Oh, okay.
Because it's nothing, and it's sort of like nothing, like a robot.
So this is the other way. So see, there's another contradiction I can get. So what did I do here? I did modus ponens on 2 and 5, right? I used the not C. That's cool, yeah. I did the modus ponens.
No, I meant you're doing good.
Thanks.
You change your voice.
Thank you. 2, what did I do? Modus tollens, 2 and 5, right? Not C and B hook C to get not B, right? And now I've got this contradiction instead. Instead of C and not C, like the first time I said, I've got B and not B. So I put 1 and 7 together by a conj, right? That's the last line, right? Now I've got the form, right? That's the X indicated I wanted a contradiction, I've got a contradiction, okay? So that ends my subproof. I know I can leave the subproof. Remember what indirect proof is? Its other name is reductio ad absurdum, reduction to absurdity, right? I'm reducing the premise to the assumption to absurdity. You think that B biconditional C is true? That's absurd. I'll show you it's absurd. Let's assume that B biconditional C is true. Look, I've derived a contradiction from it. So it can't be true. Therefore, it has to be false. Therefore, the negation of B biconditional C has to be true. This is reductio ad absurdum, reduction to absurdity. Okay, and then the last step is 9, indirect proof, and you cite the whole subproof 3 through 8, IP 3 through 8, and that's that. All right, long enough. Okay, we'll come back and we will do 11. Actually, let me say the answer to 10. So the last question on the questions and definitions is question 10, right? What's wrong here? This is a question testing your ability to distinguish rigorous applications of a rule from ones that aren't. What mistake has been made in this proof? It's at step 6, right? Step 6 saying that 3 and 4 disjunctive syllogism. That is incorrect because you do not have the D is not the negation of the second disjunct, right? Step 3, D is not the negation of the second disjunct, right? The disjunction, remember, to be a proper application of the rule, it's got to be P or Q and then not P or not Q, right? It's going to be a disjunction and the negation of one of the disjuncts. So it would have to be not D, right? If you were doing the proof, you could get not D by double negation on 3, and then you could do the disjunctive syllogism. But that's the mistake. Mistakes at step 6. All right, we'll come back and do the proofs. We'll start on the proof section, start with number 11.